Welcome to This Explainer. Have you ever looked out at a massive, towering mountain range, or maybe stared down into a ridiculously deep canyon and thought, who exactly is the artist behind all of this? Well, our planet isn't just some static rock floating out in space. It is an incredibly active, living sculptor. It's constantly molding, breaking, and totally rebuilding its own surface. So today, we're going to uncover the brilliant, dynamic secrets behind Earth's absolute greatest geographical masterpieces. So let's dive right in. From the pitch-black depths of the Mariana Trench all the way up to the towering, snow-capped peak of K2. How exactly did our planet sculpt its surface? What are the massive, hidden tools that Earth literally uses to carve out these mind-bending landforms over millions of years? To answer that, here's our roadmap for the journey today. First up, Earth's tectonic building blocks. Second, nature's carvers, water and wind. Third, coasts, islands, and oceans. Fourth, extreme biomes and ecosystems. And finally, number 5, India's majestic mountain ranges. All right, Section 1, Earth's tectonic building blocks, the engines pushing the land upwards. The sheer, raw violence of planet building is honestly just fascinating. See, the Earth's crust is made of these massive continental and oceanic plates, all locked in this incredibly slow but powerful dance. Just look at a convergent boundary. That's where plates literally crash and crumble together, thrusting up colossal mountain ranges. Then you've got a divergent boundary. This is where plates violently pull apart, allowing molten magma from the mantle to just surge upward, creating totally new ocean floors and submarine volcanoes. And finally, a transform boundary, where plates fiercely slide right past one another, deeply altering the landscape along the way. And here is the absolutely crucial point. This isn't just ancient history. 50 million years ago, the Indian and Eurasian plates collided to build the mighty Himalayas. And the shocking part? That crash is literally still happening today, right now. The plates are still pushing, which means those mountains are actually still growing. Moving on to Section 2, nature's carvers, water and wind, slicing and grinding the rock. This perfectly illustrates the evolutionary life cycle of the land itself. We start at step 1 with a plateau. That's a vast, elevated, flat piece of land formed by tectonic uplift or volcanic lava. Now give it a few thousand years, and weathering and erosion slice deeply into it, isolating a chunk into what's called a mesa, basically a flat-topped hill. Give it even more time, and continuous erosion by water and wind patiently grinds that mesa down into a solitary butte. A butte is that tall, dramatic tower of rock with the sharp vertical sides you always see in desert movies. It's just this incredible story of wind and water whittling a massive plateau down to one solitary pillar. Now, I absolutely love this next concept. Have you ever stopped to wonder how waterfalls actually happen? Well, a waterfall is essentially the dramatic story of hard rock betraying the soft rock underneath it. When a river flows, it often passes over a tough layer of hard rock, and then right onto a layer of much softer rock. The water rapidly erodes that softer rock underneath, creating a drop and a plunge pool. Eventually, that softer rock gets undercut so heavily that the overhanging hard rock becomes completely unstable, and it just collapses. The waterfall is literally eating its way backward through the landscape. Section 3 now, coasts, islands, and oceans, where the land meets the water. Okay, let's clear up a very common geographical mix-up: Gulf versus Bay. A gulf is a deep, narrow inlet that bites really hard into the landmass. It's usually carved by intense tectonic activity, like subduction, where one plate actually slides under another. Think of the Persian Gulf. A bay, on the other hand, is a much broader, more graceful curve where the land just bows inward. Bays, like the Bay of Bengal, are more often formed by the ocean simply overflowing the coastline or just eroding it away over time. Let's keep that momentum going by comparing straits and channels, because these get mixed up all the time too. A strait is a narrow body of water that acts like a bridge, connecting two much larger bodies of water. The Strait of Gibraltar, connecting the Mediterranean right to the Atlantic, is a perfect example of this. A channel, conversely, is a wider waterway passing between two neighboring landmasses, effectively separating them, like the English Channel separating England and France. So, simply put, a strait connects bodies of water while a channel separates landmasses. Just consider the awe-inspiring million-year journey of an atoll. It actually starts its life as a fiery, violent underwater volcano that just erupts and erupts until it finally breaks the surface, forming an oceanic island. Over time, these tiny hard coral animals begin to build a reef completely surrounding this island. Eventually, that heavy volcanic mountain actually dies, erodes, and literally sinks right back into the ocean floor in a process called subsidence. But the hard coral ring stays at the surface. It entirely transforms from a fiery peak into a peaceful, ring-shaped island surrounding this beautiful lagoon. How cool is that? All right, Section 4, Extreme Biomes and Ecosystems, the Textures of Our Earth. So we need to bust a major myth right now. Deserts are not just hot, sandy dunes. A desert is defined purely by a lack of moisture. Look at these 4 distinct extremes. We've got subtropical deserts, which are hot and dry thanks to high-pressure atmospheric zones. Then there are rain shadow deserts. These happen when a massive mountain range completely blocks the wind and moisture, leaving the leeward side completely bone dry. We also have coastal deserts, where cold ocean currents create heavy fog, but absolutely no rain. And finally, polar deserts. Places like freezing Antarctica or Ladakh in India are brutally cold, sure, but because they completely lack humidity and precipitation, they are strictly classified as deserts. No sand required. Now here's a fantastic rule of thumb for your next trivia night: marsh versus swamp. They are both flooded wetlands, but the secret is all in the vegetation. Just look closely at the roots. If the wetland is dominated strictly by grass, it's a marsh. But if you see trees and woody plants like the mangroves and the sundarbans, you are absolutely standing in a swamp. Remember, if it has trees, it's a swamp. If it's just grass, it's a marsh. Easy. And finally, Section 5, India's majestic mountain ranges, a localized geological masterpiece. Let's energetically map out India's colossal mountain ranges. Up north, the towering Himalayas, including the Karakoram and Zanskar, act as these absolute weather barriers, leaving regions like Leh completely dry in a rain shadow. Heading to the northeast, tea-growing hills and border ranges like the Naga and Mizo beautifully shape the landscape. Moving down south through the central Vindhyachal and Satpura divides, we finally reach the coastal Ghats and the Nilgiri Hills. It is like a giant puzzle of ecosystems. And notice the dramatic structural contrast in these southern ranges. The Western Ghats act as a continuous, unbroken wall of solid rock running right down the coast. Meanwhile, the Eastern Ghats are entirely fractured and broken up by ancient rivers over time. And brilliantly, these two massive, completely contrasting geological formations finally collide and meet at a single beautiful point: the Nilgiri Hills. So if you really want to understand the crowning peaks of this incredible region, here is your ultimate cheat sheet. Up in the north, the Karakoram is crowned by the legendary K2, the ancient Aravalli peaks at Mount Abu, while the central Satpur Range peaks at Dupgar. Michael's highest point is Amarkantak. Down where the Ghats finally collide at Nilgiri, Dadabetta stands the tallest, and the Anamalai Range boasts Anamudi, the highest peak in all of South India. The Garo, Khasi, and Jantia Hills peak at Nokraig. And finally, the highest point of the Mizo Hills is beautifully named Blue Mountain. And that brings us to the conclusion of this explainer. The single most important thing you should take away from all of this is that Earth, the master sculptor, is never actually finished. As we speak, the Indian plate is still relentlessly crushing into the Eurasian plate, which means the Himalayas are literally growing taller today. Our coasts are constantly shifting due to weather, and wind and water are still out there, patiently carving solid plateaus into solitary buttes. So I'll leave you with this provocative thought to carry with you. With the sculptor always at work, what on earth will our planet's masterpiece look like in 1,000,000 years? Thank you so much for learning with us, and as always, keep your curiosity alive.